Hi, my name is Raiden Samaru, and I'll be presenting my final project on migrating legacy systems to the cloud. The outline to this presentation will include the following sections. First, I'll give a brief introduction, then I'll present the advantages of the cloud, the motivation to migrate, the methods to migrate, cloud architecture, the conclusion, and finally a list of my references. First, let's start with the introduction. The advancing of software and hardware is a process that seems to go hand in hand, but in reality we can observe that software updates are more accessible than hardware updates. This often leaves a margin of hidden costs for an existing system to, in order for it to remain relevant and up to date. A common example is a desktop computer. A brand new desktop computer will often come bundled with the operating system and some multimedia bloatware. Also included is the required hardware such as a DVD drive, mouse, a keyboard, etc. But within a few years, most times sooner than that, the desktop computer will need updates and upgrades. Thanks to the high-speed internet, software updates are easily accessible and require only a user's time. On the other hand, hardware upgrades may require additional components such as an increased amount of RAM, a second hard drive, a better graphics card, etc. etc. These upgrades can cost time and money, and in some cases, upgrading can be too costly, in which case replacing the desktop computer altogether may prove to be a better alternative. Businesses and enterprises are no exception. Upgrades and updates are essential for any company that wishes to remain up to date with current technology and communication. But unlike a desktop, such large-scale systems cannot simply be scrapped when regular upkeep becomes too costly. This presents a new challenge and demonstrates just how crucial the migration of a legacy system can be. So let's look at a legacy system. What exactly is a legacy system? Well, a legacy system is described as an old method technology, computer system, or application. In some cases, the legacy system may not be in use, but still plays a significant role on the current system because of historical reasons. In this way, even older systems, such as legacy systems, are necessary. So why keep a legacy system? There are many reasons to keep a legacy system. There may be limitations to rebuilding or replacing due to the system's complexity or size. Sometimes the system is already sufficient and there's no reason to change it. Sometimes the loss of time and high costs for retraining users on a new system may be too great. The system may require constant connectivity and cannot be disabled. Also, there may be a limited knowledge on how the system works, or maybe the system was not well documented after the owner moved on. While replacing a legacy system may be out of the question, there's still a need for keeping the systems up to date. With the increase of new technology and trends, the solution for an aging legacy system may be migration using cloud computing. Cloud computing is described as a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources that can be quickly provisioned with minimal management or service provider interaction. The nature of cloud computing provides a means of delivering the necessary services and resources to an organization without compromising the integrity of the legacy system. Using cloud computing does not necessarily mean remaking or deleting an existing working system, but rather transitioning that system to a different state using methods of migration. Now let's take a look at some of the advantages of the cloud. There are many obstacles to consider before moving a legacy system to the cloud. A legacy system must be considered from both a business and performance point of view in order to fully take advantage of the cloud. Some aspects of the cloud that may be useful to legacy systems may be agility, virtualization, reliability, scalability and elasticity, performance, and maintenance. Agility refers to the ability to respond quickly and precisely to unexpected and changing demands. This allows the user to use resources, when demanded, to provide support under any conditions. Virtualization refers to the ability to allow storage devices and servers to be utilized and shared. With virtualization, applications and other software can be easily migrated across one or more physical servers without having to worry about location. Reliability refers to the ability to consistently deliver data across a network of users. This can be increased if multiple locations are used to house the same data. Reliability ensures business continuity to keep critical business services available. It also plays a major role in disaster recovery in the event of a major failure. Scalability and elasticity refers to the supply of resources and services to different amounts of users without manual intervention. Scalability is a planned level of capacity that is expected during normal operations. This way, resources can be efficiently allocated in the future. Elasticity is the ability to increase the current workload dynamically and on demand. Performance refers to the ability to monitor usage of the cloud and the use of web services. Web services are necessary for the concept of always-on cloud utilities. Maintenance refers to the ease of maintaining cloud applications, since cloud applications do not need to be installed on individual terminals of the user. This allows the cloud to be accessed from various locations. In cloud computing, there are typically three service models: software as a service, platform as a service, and infrastructure as a service. Software as a service refers to the application layer of the cloud and consists of on-demand software over the internet, such as iCloud and Google Apps. Platform as a service refers to the middleware layer of the cloud and consists of resources for software development, such as Microsoft Azure. Infrastructure as a service refers to the infrastructure layer and consists of resources such as networking, storage, and virtual machines. Some direct benefits of migrating to the cloud may include the ability to securely manage code and documentation, constant support and monitoring, the ability to combine commercial and open source tools, decreased downtime of applications, the ease of upgrading, and support for a mobile or dispersed workforce. This table shows some of the challenges of a legacy system and the levels of service that can be used on the cloud to overcome those challenges. So, for example, we take a look at the first one, securely managing code. That can be handled using the software level or the platform level. You look at a different one such as downtime and disaster recovery. You'll notice that can be handled using software level and infrastructure level. So a lot of challenges have more than one solution, and there's a lot of overlap since most problems can be solved using a combination of services. Now let's take a look at what motivates the migration of legacy systems. With the need to better manage, secure, and support the information and technology end of a business, migrating to the cloud is a smart option for business owners today. The most obvious advantage to moving to the cloud include reduced complexity, increased scalability, and lowering of costs. In addition, there are trends in the IT community that motivates the migration of legacy systems to the cloud. Such trends include the increased use of cloud from home, as well as the slow growth of traditional IT. Recent studies show that home users of cloud-based services are more likely to support and promote cloud-based services of their employers. This may seem insignificant, however, personal use of the cloud and the ability to bring mobile devices to work are significant motivators for enterprises to migrate to the cloud. Dependence on the cloud is expanding outside the workforce with or without the organization. A survey of over 1,200 tech professionals revealed that the personal use of the cloud plays a major role in the decision for corporate to adopt cloud services. Of the companies surveyed, 73% of them claimed that their employees' use of the cloud affected the company's decision to move from traditional IT to the cloud-based infrastructure. Overall, 61% of the businesses agree that BYOD, which is bring your own device, has accelerated the move to cloud-based services. Current methods of maintaining legacy applications are questionable if an organization wishes to attain a competitive edge. Traditional IT services are unable to morph into a cloud-based software model and show slow growth among IT services compared to the pace of public cloud trends. According to Gartner, the worldwide market for cloud services capped $91 billion in 2011 and is expected to be valued at $109 billion by the end of 2012. It is estimated this number will reach $207 billion by 2016, which is a 100% growth rate. On the other hand, the growth of IT spending has increased only by 3% from 2011 to 2012. This lack of growth shows evidence of IT services coasting in the future. Although traditional IT has better security options, the inability to offer services of software, middleware, and infrastructure on demand without being in-house will prove costly in the long run. Between hardware, locality, power, and insurance, traditional in-house IT is noticeably more expensive than comparable cloud-based services. Most businesses will achieve a return on investment within 3 years of moving to the cloud, according to Cloud Computing Center. Now let's take a look at the methods of migration to the cloud. According to Gartner, there are 5 alternatives when moving legacy systems to the cloud. These alternatives include rehosting, refactoring, revising, rebuilding, and replacing. Rehosting focuses on the infrastructure as a service level and requires that the system be redeployed to a different hardware environment. This method requires changing the configuration of the application infrastructure. Rehosting a legacy system without changing its core architecture makes migrating to the cloud a fast process. This allows for the quickest way of migration, but can also be a disadvantage since certain attributes are lost, such as scalability and elasticity. Refactoring focuses on the platform as a service level and requires running the legacy application on the cloud's provider's infrastructure. This process allows developers to recycle code by reusing the language. This also allows a balance between strategy and selection. Note that platform as a service varies based on the cloud provider, and some functionality may be absent to the developer using the method of refactoring. Revising focuses on the infrastructure and platform level and requires modifying the existing code base. These modifications are required to bring legacy systems up to speed, so rehosting or refactoring can take place. This allows legacy applications to take advantage of the cloud's infrastructure. A disadvantage of revising is upfront costs of assembling a development team for larger projects. Also, revising is time consuming and not immediate. This is based on the size of the revision being done. Rebuilding focuses on the platform as a service level and requires discarding the code of a legacy system and redesigning the application. Even though this means scrapping the existing code, it allows unused features of the cloud's platform to be incorporated into the new design. These features may improve a developer's productivity, such as pre-built components and libraries. The disadvantage is that starting from scratch could force a legacy system to develop at a locked-in or fixed price. If the price changes in the future, the application may fail, and this could result in the loss of customers. According to Gartner, there are 5 alternatives when moving legacy systems to the cloud. These alternatives include rehosting, refactoring, revising, rebuilding, and replacing. Now let's take a look at the different cloud architectures. In most cases, the entire legacy system will not be migrated to the cloud. There are several reasons for this. A legacy system may require sensitive data. Perhaps a business may already have its own dedicated servers, or a business may not want to risk the security of a customer's information. Different amounts and forms of data will be migrated to the cloud, which results in the use of various cloud architectures. Such cloud architectures may include public, private, or hybrid cloud. The private cloud, also known as corporate or internal cloud, is a cloud computing environment that resides within the organization's local system. Legacy systems have a tendency to receive higher security due to local firewalls. This is a great option for businesses that already have their own data centers, which allows for cost and security savings. The organization is responsible for updating, maintaining, and managing their own data. The public cloud is a cloud computing environment that resides on an outside third-party system. Organizations access data in virtual servers using the cloud provider's data centers. Management and updating is handled by the provider, and security is often a concern with public clouds, since the user's data resides on an external source. This is not to say the public cloud is not secure, since a user's data is isolated and accessed only using a username and password. The hybrid cloud is also known as the hybrid IT, and is a cloud environment that uses a combination of private and public cloud. The organization handles some data locally while using resources and service from an external source. This allows the user to take advantage of the cloud provider's benefits, such as virtualization, without exposing sensitive data. Businesses such as Netflix, Heroku, and Foursquare are companies that are known to use the hybrid cloud architecture. This table shows some of the requirements of a legacy system and how they can be met on different architectures of the cloud. So, as you can see, there are advantages and disadvantages to each type of cloud, and they have to be considered based on the legacy system themselves. So, based on the table, you can see the different architectures that are used for different requirements. For example, the internal data centers can be used from both the private and hybrid architectures. Then you have things like high level of security, which is typically only obtained through use of a private cloud. Not to say that the other clouds aren't secure, but the highest level of security will obviously be something done privately, since there won't be any concern with the information going public or being on an external source. And of course, external management, that will be handled by more of the public side of the cloud, also the hybrid side of the cloud. In most cases, the entire legacy system will not be migrated to the cloud. There are several reasons for this. A legacy system may require sensitive data. Perhaps a business may already have its own dedicated servers, or a business may not want to risk the security of a customer's information. Different amounts and forms of data will be migrated to the cloud, which results in the use of various cloud architectures. Such cloud architectures may include public, private, or hybrid cloud. And these are my references that I use for a lot of the stats and summaries used in this presentation. And that is the end of my presentation. So thank you for your time, and I hope you enjoyed it.